The POE final exam prep practice test answers for pages 21 through 24. These questions are over statics and structures. So number one, of a quantity that has a magnitude and direction, that is going to be a vector. According to the figure, what's the value of the reaction force that occurs in the vertical direction at point A? So we're trying to find what pressure is pushing down right here. Now, since these two dimensions are the same, you can safely assume that this 10 pounds is going to be divided equally between the two sides. So this side and this side. The 10 divided by 2 is going to equal 5 pounds. So 5 pounds here, 5 pounds here, 5 pounds. The sine of 5/13 is equal to 22.6 degrees. Number 4, it is asking us to find the length of the line in the x direction. So we have to go through and kind of assume that there's a line here, and then this line down here is what we're trying to find the length of. In order to find the length, you're going to have to go back to SOHCAHTOA. And when you do SOHCAHTOA, you have to have an angle and a length of the line. So in this case, this 100 pounds is actually the length of this side of this triangle. And that one is your longest line. Remember, that is your hypotenuse. So this is a 90-degree triangle. We're trying to find x down here. So we have an angle of 30. We know we have the hypotenuse, and we are looking for the adjacent line, so we're going to use cosine. So to set this up, cosine of 30 degrees is equal to my adjacent over the hypotenuse. So cosine of 30 degrees is equal to adjacent, which we don't know. The hypotenuse we do know is 100. So what we're going to have to do is get A by itself, and the only way to do that is multiply this side by 100 and this side by 100. So 100 times the cosine of 30 degrees is going to give you a length of 86.6. So my answer is A, 86.6 pounds. Number 5, moment of inertia is a cross-sectional property that gives the engineer an indication of the stiffness of the particular shape. Its value can be used to A, calculate the amount of deflection that occurs in structural beams. We jumped over to just do 9 through 12 in this case, so don't worry about that one for this part. Number 9, a true 2x6 beam. The actual dimensions are 2 inches by 6 inches, so don't assume that this is a board that comes from the store that is called a 2x6, which is actually a 1 3/4 by 5.5, or 1.5 by 5.5, excuse me. This is an actual size. So it's standing upright. The shorter side is the base in this case. So the shorter side is the 2. And the taller side is the 6. So using moment of inertia is base times height cubed over 12. So plug in my values. Make sure that you plug in your 2 multiplied by your height alone cubed. It's really important to only make sure that that part is cubed. Divided by 12. You punch that in your calculator, and you're going to get an answer of 36. Moment of inertia is expressed in terms of inches to the fourth. So D. Number 10, given the lengths of the side of the following triangle, what's the value of the angle theta? Well, first thing that you actually have to do is find the length. Actually, never mind. You don't need to worry about the length. I thought we were looking at the y value. You're just asked to find the angle so what you're going to have to do is use SOHCAHTOA again. You have this angle, you have this length of this line and this length of this line. It is the adjacent and the hypotenuse lines. So you're going to use cosine. So the cosine of theta is equal to your adjacent over your hypotenuse, which is 20. So you're trying to find theta. So all you really have to do is do the inverse of 16 divided by 20. And that's going to give you the 36 point, I get actually 36.86 in my calculator. So 36.9 looks like it's going to be the answer. 11, given the length of the side of the triangle above, what is the value of y? So I was jumping ahead. So now you've got to find the length of the line. All that is Pythagorean theorem. A squared plus b squared equals c squared. So plug in your values. We'll just call a squared what we don't know. We're just looking for it. It doesn't matter. Plus b squared, which is going to be the 16, equals c squared, which is always going to be my hypotenuse. That's going to be 20. So a squared plus 16 squared is going to be 256 equals c squared, which is 20 squared is 400. So we're going to just get rid of the 256, so we're going to subtract it here. Subtract it here. So a squared is equal to 144. Square root of 144 equals 12. So my answer, D. And number 12, the x component of the vector below would be what? So we are being asked to find the length of, if there's a line right here. Call this our 90. We have an angle down here. We have the length of this line given is 75. We're trying to find the opposite. So SOHCAHTOA again. In this one, you're going to use sine as well. So the sine of 40 degrees from here is going to be equal to your opposite over your hypotenuse, which in this case is 75 from here. So to get the opposite by itself, we're going to do 75 multiplied by the sine of 40 degrees. And that's going to come out to 48.2. But you got to be careful. Don't just jump and pick C. C is actually incorrect because right here, this is 0.00. So if this is 0, 0, this is going to be 1, 2, whatever. In the positive direction, anything that goes this way is going to be a negative number. So my answer is negative 48.2. So that's A. Number 13, the y component of the vector above, that's actually on your guys' packet, the last page. What you have to do is you have to kind of give yourself a sketch. Write in your values. This was 75, and we just calculated this out to be 48.2, and we want to find this. So all you're doing, Pythagorean theorem again. So my a squared is going to be my 48.2 plus my b squared, we don't know, equals my c squared, which is, that's 75 squared. So 48.2 is going to calculate out to 2323 plus b squared equals 75 squared calculates out to 5625. We got to get rid of the 2323, so get rid of it on this side, but you also have to be fair and take it away from this side. So now my b squared is going to be equal to 3302. Square root of 3302 is going to equal 57, and I guess right about 0.6 is what I'm getting. So 57.6. I need to charge my battery. Okay. I've got a battery charging. We're good to go. Back at it. Number 14, if another 10 pounds in the positive x direction were added to the vector above, what would be the x component of the resultant force? So all that's saying is, remember, this is our origin down here. So 0, 0 is here. These are positive numbers. These back here are negative numbers. So this is actually negative 48.2. And all it says is, if you add 10 pounds in the positive direction, what's my resultant force? So negative 48.2 plus 10 is going to be 38.2. So negative 38.2. Number 15, the moment of the wrench below would be what? So first setup, moment equals force times distance. So now I need to look at my force, and it's given here, it's hard to see. That's going to be 20 pounds multiplied by my distance. Now in this case, this shaped wrench, you do not have to worry about this part. That has nothing to do with your distance in this case. You're looking at the overall distance because you're applying the force out here. The only reason this wrench is shaped like this, maybe it's a specialty wrench, maybe it needs to go around the corner or something. You don't know and you don't really care. So you got to look at this number and this number. So if this is 2 and this is 4, my distance is going to be 6. So my moment is going to be 120 foot-pounds, or pound inches. Excuse me. So D. 16, the free body diagram that is correct, is going to be option D. Force and velocity are vector quantities. And then static equilibrium is when everything is at 0. Number 19. What this is showing is what's called a resultant force. So you have something actually pulling here and pulling here, but you really don't have something pulling here, but it acts and feels like it. So if it acts and feels like it, that is actually what's called a resultant force. 20, because this is a roller, okay, this would be a pinned. It's going to have two reactions. And in 21, the combined magnitude of the forces at R1 and R2, it's actually really simple. So if you look here, the force at 1 is 4, and the force at 2 is 4. Because the distance between A and B and C and D are all 1 foot, they're all equal, so you don't even have to worry about it. You don't have to worry about what's going to happen here and here. It's going to be just whatever these two are together, because there's no other force. Notice there's not an extra force here. So it's just these two forces. So the combination, so what's happening here and what's happening here, if this is a total of 8 pounds pushing down, there's also going to be 8 pounds pushing back up. So that's it.